So this talk came out of some conversations we had around the office about what is module and how does it work. And we eventually arrived at the point, what even is the module command? And it'll become clear what that question means as we go along. So just a quick, for people who don't know already, what module is. So HPC clusters provide, in general, a large amount of software. So on the Sandy Bridge machines that we've got in Swansea, this was 440 modules. And not all of this can be in the environment at once. So you've got lots of different versions of the same compiler. In principle, you could have this in the same environment if you versioned each executable. So when you wanted to compile something, rather than saying ICC, you said ICC 2017 Mark III. But that's a bit cumbersome to type. So instead, we'd like to be able to swap in and out different bits of the environment as we need them. So to do this, we can install each package in its own folder, and then on request, add the package location to the path, and then also to man path, and edit any other environmental variables that software sets when it's installed. So to use module, we can say module eval to list what modules are available. Okay. Then we can load some with module load, and then we can list the ones we've got available. So list the ones that we've got active with list, and then unload them when we're done with them, and then we can, if we want to throw out all the modules and start from scratch, we purge them, and we're back to where we were when we first logged in. And here's where you start to get suspicious. But
can I ask?
You can, go for it.
What is the difference between unload and purge?
Unload unloads one module, purge gets rid of all modules. So load and unload take one or more module names as an argument, whereas eval, list, and purge work without arguments. So before we come on to our suspicion, Mark has requested I put this promise from the designers of module. Modules can be loaded and unloaded dynamically and atomically in a clean fashion. This is the commitment on the GitHub page for environment modules. So let's do this. So I have just logged in. So F90 is not set. I export F90 as gfortran. Okay, that works. Then I load the Intel module. That changes F90 to the ifort. Now I unload the Intel compilers. I echo the environment variable, and it's been squashed back to nothing. So we start to see that this is not as dynamic or atomic or clean as it claims on the tin. So with that aside, we come to our first concern. Executable scripts run in a subshell. So we've got this command module that's editing our environment, but it's run like a program. So how's it doing that? So executables can't change the environment. So if you want a script to change the environment, you have to source it. You source or use dot or whatever the command is in your shell to run something under the current shell in the current interpreter that will then let it change the environment. So this is where the question, what even is module, came from. It's not a script. It's not an executable because we're not sourcing it. So what is it? So we thought, it must be an alias. So module is just an alias to source something. Okay, that makes sense. So which module? Which command doesn't just show you where in your path something is. If something's an alias, it will also tell you what it's an alias to. So which module? No module. Nope. So where is it? Where do we define this command? And what even is it? It's not an alias. It's not an executable. It's not a script. What's going on here? So as another aside, you may have noticed, if you've used module, that if you have a very long list of available modules, like the 440 on Supercomputing Wales, you want to use grep to find a particular module. Doesn't work. Grep can't do it because it's outputting everything to standard error. Why? Why? I'm listing something. Why is that an error? Why can't I get that on standard out? The reason will become clear. So some progress. So if something's not an alias and not an executable, something must be being set on login to tell the system to activate this command, whatever it is. So we look in /at/profile.d, we find something related to modules. Okay, this is promising. So we have, okay. So when we log in, we're sourcing this module, this initialization of module for the current shell, whatever the current shell is. Okay, the rabbit hole goes further. Let's go and look at the contents of this init file. So I'm going to use the one for bare sh because it's probably the simplest. Aha! Module is a function. I don't know about you, but I don't use functions in the shell, like, ever. So this was a surprise to me because, oh yeah, Bash does have functions. I was tangentially vaguely aware of that, but it was a surprise to see it actually used. And then you look at the right-hand side, it's like, ah, okay, things are getting evaluated. Okay. So let's try and work out how this works. So we want to work out what this module CMD is. So turns out this module CMD is not a script, it's actually compiled because for some reason it's got a TCL interpreter built into it. So if you look on GitHub, you find it's 7,392 lines of TCL. Let's look at a module file, because I don't really want to go into 7,392 lines of TCL because I don't know TCL that well. And a lot of it, I skimmed through it, a lot of it is boilerplate or processing or text manipulation or whatever. It's stuff, it's not interesting. So if you look at a module file, it'll be hopefully more informative. So you can get that from GitHub if you're interested. So let's look at this other script that runs in /at/profile.d that sets up default modules. So this is on Hawk. This is on the new Cardiff Super Wells cluster, and you see we get all these module use commands. So the right-hand side is just directories, and we're telling module to look in these directories for modules. Okay. So let's look at what we find under /app/modules. You see there's this directory tree of the level that module use was looking at, and then on the right-hand side, names of modules, or it's treated like a tree structure of modules. So let's pick one of those out and take a look at it. In fact, I'm not going to use /apps, I'm going to use /app because it has some interesting points that we can discuss. So this is the top of the file. So we can see here, the first thing you can see is that module files are TCL programs. So don't worry too much, you don't need to know that much TCL to be able to write one, but it helps in understanding it to know that it is a program in its own right, written in some language. So you can set variables that the module CMD will then interpret, things like application name, version, that kind of things that the module will need to know about. Then we look further down. So yeah, it executes these and does stuff with the rest. So if you look further down the file, we can see this is a help message. So every module, I think, has to define this module's help function that if you ask for help on a module, tells you things about the module. You can see this is putzing to standard error. We're starting to see where all these messages going to standard error were from. Why? Why are you putting things to standard error? So looked at further down the file. So this is something to do with setting the ulimit. So this is why I've chosen this module, is because it has this particular snippet of coding. You can see, okay, if we're running under sh, then we put a shell command. Why are we sending a shell command to standard output? And it's when I read this, or some code like it, because it was a while ago I saw it the first time, I thought, wait, no, surely not. This is horrifying. That is the thing that was on the screen earlier. You have an eval, and you have the output of the script. So module CMD does everything in that TCL file, including outputting to standard out. Then any shell commands in that standard output are evaluated and run in the current shell. So where on the previous slide it said puts ulimit-at unlimited, that means then when you load this module, it outputs that to standard out, that gets passed to eval, which then sets the ulimit. So this is where your brain starts to melt slightly. Everything is just being done by this huge hackery involving eval. So all the actual work is done inside module CMD. The output of module CMD is then passed straight into eval, which runs in the current shell, and then commands run by outputting to standard out, which means eval runs them. So that means if you want to display any output the user can read, it has to go to standard error. So we can cross-check this if we look in the source for module CMD. This those 7,000 lines of TCL, which I've just picked a snippet out of. So this is there's a switch statement looking at what kind of shell you're running to export, depending on what your shell is. And so you can see if our shell is SH, then we put this export to standard out. So if you want to export something, we tell standard out export. Incidentally, this does support a wide range of shells, things like TCL, CMD, that's the Windows command interpreter. It also supports Python as a shell. So it's surprisingly versatile in what it supports. But yeah, it is always outputting to standard output and then running using eval, which is still slightly horrifying. So I mean, if we go back to that, this is why module eval outputs to standard error. In principle, you could have made this function more complicated. You could have had some kind of logic to check if you were doing a command where you might actually want to pipe it, and it's never going to run anything, it's never going to pass anything that wants to be run to eval, then you can have a wrapper that's called eval only if you were doing functions that didn't want that. But they've chosen to move all of that logic into TCL, even though it's no simpler in TCL, I don't think. I mean, it's a lot of boilerplate. It's not like Python where you can just excuse me, use argpass and say, I want to pass all these arguments. It's not that simple. I think it's still doing things by hand. So if you're going to do things by hand, why not do it in such a way that you can pipe? But that's just my rant. So other things you can do with module. Now we've seen the structure of a module file and know how it works. So we recall you have this use/app/modules/physics, and that's just a directory on the right. So in principle, you can just create your own directory and use that. So create a directory in your home directory, say module, use that directory, put some module files in that, and you've got your own modules that you don't have to get your sysadmin to set up for you. So that's what I just said. This is actually built in. So module has this use.own module built into it. And that looks in your home directory in a directory called private modules. So if you create a directory called private modules in your home directory and module load module.use, then you can just pull in any modules you like. So let's talk a little bit about how you would write your own module. So this is a poorly connected VGA cable. No, this is a short TCL program that is a generic module file. And I did grab this off the internet, so I will put a link in the video description on YouTube, and if you want, I will tend to send you the link if you're in the room. So yeah, comments start with a hash, like most scripting languages. We've got this boilerplate TCL to tell TCL that it's TCL. Or to tell module that it's TCL, actually, I'm not sure. But then you've got this module's help function, which we talked about, that of course directs all its outputs to standard error and tells the user what the module does. You've also got this module what is, which is like a shorter description that I think shows up if you do certain kinds of module listing, I'm not sure. you can have prerequisites that this module must be loaded in order to load the module we're writing here. In general, at least on supercomputing worlds, we don't use that. You see a lot of those lines commented out and replaced with module load, because if you have a prerequisite, then module will just error out and say, you need to have loaded this module before you load this module. If you're going to do that, why not just load it for them? Computers should not error unless there's an unrecoverable condition.
There is a conflict.
Then you get an error. So you can say this module conflicts with some other module, and then there'll be an error. So that doesn't cause a problem, even if this module loads another module. If it conflicts, you'll still get the error. It will still fail to load. So yeah, we can load other modules. So you can make things like meta modules where you load a bunch of modules in one module.
So presumably you want to put the conflict before you actually do any changes to the environment. Otherwise, presumably it breaks. I imagine it just exits when it gets the conflict.
That's a good question. I haven't traced the execution as to whether it checks, whether it reads the...
It would have to delete previous standard out. So presumably it doesn't do that.
Yeah, because it doesn't buffer, it just puts, doesn't it? It doesn't buffer its output, so yeah, put conflicts before everything else. Then you can set environments, you can do all of these little commands that are defined by module. So, kind of interesting, this is how you pass arguments to functions or to subroutines in DCL. But, yeah, so it's got this utility function for appending to all your different paths. So the things you normally want to do is path and add path. If you're editing LD library path, then something's gone wrong, but okay. A lot of people do it anyway. So yeah, that's defining your own module. So in principle, you could copy and paste that, put your own executables in there, and have them available via module load use.own. And yeah, that's all I got really. It's not that much to say about the module command. I put the picture there because I reused the template from the last talk I gave, where I wanted to put a pretty picture at the end. So enjoy the beach scenery from a couple of months ago.